Hey YouTube, in this video we're going to explore how to factor trinomials some more, except for we will look at these trinomials that are quadratic in the form ax squared plus bx plus c, where a specifically equals something other than 1. So in the previous video we could find out, what the factors of something like maybe this is just by saying, well, can I think of two numbers that multiply out to be this last term and add up to be the middle term? And in this particular instance we could say, well, this would be x and this would be x. And then I could say, well, how about a positive 1 and a positive 2? Because we would get here 3 total x's in the middle. And of course, we get our x squared from our first part of our multiplication and our positive 2 from the last part of the multiplication. That only works when this a value is 1. So when we have something else, like 2x squared plus 5x plus 3, a little guess and check is going to be needed. So what I'm going to do is I'm going to give you some advice. And we're going to say, well, what we're really doing is we're undoing this FOIL. We want to go backwards into the binomials that when we multiply them, we get this expression right here. So we're factoring this into two things we can multiply to get this. So what we'll do is you always start with the f part. That is, we need to find something that we could put here and here that when multiplied, come up with our first term here. So when we say, well, what can we multiply to get 2x squared? Well, the only things I can think of are 2x and 1x. So once you get that f part, what we're going to do is we're going to go after this last part. So this last number here, we say, can we think of two numbers that multiply out to be a 3? Now I can think of two. We could think of like 1 and 3 or negative 1 and negative 3. And because we need this middle term to add up to be a positive, we're probably going to use these positive 2 right here. So here's the thing. These will not add up to be the middle term. That's not what we're looking for here. What we need to do is guess, well, which of these pairs here, when we put them in, are going to give us what we need. So what I'm going to do is I'm going to choose to put in, positive 3. How about this? Positive 1, positive 3. Like this. And what I want everybody to know is at this point, because of FOIL, we would say that the first two do indeed multiply out to be this first term. Like it's inescapable that they do. And now we would say that the last two here, guaranteed. We're guaranteed that we get this 3 right here. The only thing we're not guaranteed to get is this 5x in the middle. So here's where this little guess and check comes in. You get your first two in, your last two in, and then what we always need to do is we check. We check the O and the I. And so I know this. I'd get 2x times a 3 here, which would give me a 6x. And I would say on the inner, I would get 1 times x, which is a 1x. And when I add those up, I get 7x. And the thing here is this. I don't need a 7x in the middle. I need a 5x in the middle. So if this doesn't work, this is where this guess and check part comes in. What we'll do is we'll say, well, I still know that I have a 2x and an x. I still know this. And I still know that I have a 3 and a 1. It's just that maybe I switch my 3 and my 1 around. I say plus 3 plus 1. So now we don't need to go through checking this whole thing again. It's always just check your outer and your inner. And in this case, I'd get 2x times 1. That would be a 2x. And I would get 3 times an x, which is a 3x. So if we FOILed this out, these two would add up to be a 5x. And that is indeed the term we have here in the middle. So this would be our factored expression. So let's take a look at these three trinomials that we want to factor. You'll notice that they're all in that ax squared plus bx plus c, or standard form. But we say also that all the a values are not 1. So we're going to have to do some guess and check here. So I would say, let's do this. How about we start with, I need to put two things in and multiply out to be my first term here. So that would be maybe 2x and x. Not really many choices there. And they say, well, what could I put in that multiplies out to be a 3? Well, kind of thinking back to this last example up here, I realized that if I were to put this plus 1 plus 3, check this out, I get 6x and 1x. And that adds up to 7x, and that's what I needed here. I didn't need to check this last one here because I knew that by putting a 1 and a 3, I would certainly get that. So taking a look at this next one, we say, well, 3x squared plus 5x minus 2. Let's go ahead and say, well, this, if it factors, multiplies out to two binomials. We'll start with the first two terms that would give us the 3x squared. So this must be a 3x and a 1x. Not many choices there. Now, the interesting thing here is factors of negative 2. We say, what multiplies out to be a negative 2? So like a negative 1 and a positive 2, or a positive 1 and a negative 2. So we're just going to guess. I mean, like, I'll just go straight up with this first option I have here without even thinking about it. And what I'm going to do is I'm going to check my outer and my inner. And I say, well, 3x times a positive 2 is a 6x. And a negative 1 times an x is a negative x. And when I add these up, I get a positive 5x. And hey, you know what? We got lucky. As a matter of fact, this is the factors form of this original expression. If I had been wrong, I'd maybe switch my 2 and my 1 around, or switch the signs on them so the 1 was positive and the 2 was negative. So now this last one, let's take a look at it. We say if this factors into two binomials, then we would have in the front what? Well, it'd have to be a 2x and an x to multiply out to be this first term. So now let's look at our L part of the FOIL. We say what numbers multiply out to be a positive 15. So it's either a 1 and a 15, or a negative 1 and a negative 15, or a 3 and a 5, or a negative 3 and a negative 5. I'm not going to list them all. We are not this time looking for something that adds up to 11. We're just guessing. So how about I guess, and I'll tell you this, if you ever have factors that are very close together, choose those before you choose ones that are very far apart. And so I'm going to go with plus 3 plus 5. Just guessing here. I don't know what that gives us in the middle yet. I do know it gives us the F and the L part. So outer, inner, we say 2x times 5 is 10x. And then 3 times x is 3x. And these add up to 13 x's, and I need 11 x's. So let's try this. Let's try this again. Except this time, we'll put our 2x and our x here. We'll just switch my 3 and my 5 around. How about plus 5 plus 3? We'll just check this again. So this time I would get this 2x times 3 is 6x, 5 times x is 5x, and these certainly add up to being 11x. So this would be our factored expression that is equal to the original expression here. Cheers.